Insert a voltmeter across the ends X and Y of the series combination of 3 resistors. Plug the key in the circuit and note the voltmeter reading. It gives the potential difference across the series combination of resistors. Let it be V. Now measure the potential difference across the two terminals of the battery. Take out the plug key and disconnect the voltmeter. Now insert the voltmeter across the ends X and P of the first resistor. Plug the key and measure the potential difference across the first resistor. Let it be V1. Similarly, measure the potential difference across the other two resistors separately. Let these values be V2 and V3 respectively. Deduce a relationship between V1, V2 and V3. So the potential difference V is equal to the sum of potential differences V1, V2 and V3. That is, the total potential difference across a combination of resistors in series is equal to the sum of potential difference across the individual resistors. That is, V is equal to V1 plus V2 plus V3. In the electric circuit, let I be the current through the circuit. The current through each resistor is also I. It is possible to replace the three resistors joined in series by an equivalent single resistor of resistance R, such that the potential difference V across it and the current I through the circuit remains the same. Applying the Ohm's law to the entire circuit, we have V is equal to I into R. On applying Ohm's law to the three resistors separately, we have V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. So IR is equal to IR1, IR2 plus IR3, or we can say RS is equal to R1 plus R2 plus R3. So we can conclude that when several resistors are joined in series, the resistance of the combination RS equals the sum of their individual resistances R1, R2, R3 and is thus greater than any individual resistance. यानी किसी भी सर्किट में अगर बहुत सारे रेजिस्टर्स हैं तो उन सारे रेजिस्टर्स का जो रेजिस्टेंस है वो जो टोटल मिलके रेजिस्टेंस होगा वो उस पूरे इलेक्ट्रिक सर्किट का रेजिस्टेंस होगा. यानी एक रेजिस्टर के रेजिस्टेंस से ग्रेटर वैल्यू होगी उस पूरे सर्किट के रेजिस्टेंस के. Let's see an example now. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistance are connected to a 6 volt battery. Calculate the total resistance of the circuit and the current through the circuit and the potential difference across the electric lamp and conductor. So the total resistance R is equal to R1 plus R2. तो R1 हमें दिया हुआ है 20 ओम और R2 हमें दिया हुआ है 4 ओम. सो RS is equal to 20 ohm plus 4 ohm is equal to 24 ohm. The total potential difference across the two terminals of the battery V is equal to 6 volt. Now by Ohm's law, the current through the circuit is given by I is equal to V upon RS. So 6 volt upon 24 ohm is equal to 0.25 ampere. Applying Ohm's law to the electric lamp and conductor separately, we get potential difference across the electric lamp. V1 is equal to 20 ohm into 0.25 ampere is equal to 5 volt. And that across the conductor V2 is equal to 4 ohm into 0.25 ampere. It's equal to 1 volt. Suppose that we like to replace the series combination of electric lamp and conductor by a single and equivalent resistor. Its resistance must be such that a potential difference of 6 volt across the battery terminals will cause a current of 0.25 ampere in the circuit. The resistance R of this equivalent resistor would be R is equal to V upon I 6 volt upon 0.25 ampere, that is 24 ohm. This is the total resistance of the series circuit. It is equal to the sum of the two resistances.